Why did I choose that graphic? Does anybody know? Any ideas? No? Yeah? Oh, I like that. I'll use that one. I didn't have a good reason. I was looking for one. This is pair programming, by the way. Welcome. Who here has experience with JavaScript? Just making sure. Okay. And test-driven development. Has anyone here tried it? Who is actually doing it now? These days, not right now. These days. Who tried it and stopped doing it? Okay. Who is using TypeScript? Okay, and regular, vanilla, hardcore, old school. And then some people are not this or that. I don't know what that is. So welcome. My name is Roy Osherove. This is my Twitter address. This talk is basically the first talk that I'm doing based on the new book that I'm writing called The Art of Unit Testing in JavaScript. I'm rewriting it, the entire thing in JavaScript. So if you want to, the first 3 chapters are basically ready, and they should be ready for kind of public consumption in the next month or so. So if you want to, if anyone here in the audience wants to get the first 3 chapters just for free, just to see what this is all about, and maybe give me some feedback as well, just go to this URL and then put your email address there. I promise that I'll spam you about future editions of the book as well. So just make sure that you understand this. But we might actually learn something together. Why am I doing this? This talk is all the stuff that I learned about unit testing the hard way. And in JavaScript, there are some changes from the book that I wrote in .NET, but some patterns actually still remain, which was very nice. When I got into JavaScript in the past couple of years, it was a beautiful journey because JavaScript has this both kind of functional, but also kind of ugly, but also kind of beautiful kind of thing going on. So I had to try to reimagine a lot of the ideas that I had, where they fit. Now, in this talk, we're going to do 3 things. We're going to talk about the test-driven development process and origin, because this talk is understanding TDD. So it's not just about showing how it works, but it's to explain why it works the way it works, or why I kind of like it. And then we'll finish with some common questions. I'll show a demo of a kata, which is called the password verifier, which I like to do. I created a kata called the string calculator, but the password verifier is my new favorite that I made a while ago. So, for those of you who have no experience with TDD, or have but don't know where it came from, I first learned about TDD from Extreme Programming. There was a great book called Extreme Programming Explained, and there are a bunch of other books after that with Extreme Programming something. One of the practices, technical practices in XP, is test-driven development. And what I like about it is that you can take that practice and apply it anywhere, regardless of what is the methodology in your organization. That means basically that even if you're working in waterfall, if you're working in CMMI, if you're working, it doesn't really matter if you have a known methodology or not. This is a practice between one human and their computer. Just like debugging, okay? You don't ask anyone for permission to do debugging. It's the same thing here. It's basically just a development technique. You can use it for many other things, and I think one of the most common annoying things about TDD is that everyone understands it a bit differently. So here are 4 common meanings of TDD and how people interpret it. Some people interpret TDD as test first development. You might have heard this. Some people say, no, it's test-oriented. What is the difference? Test-oriented is people who say, oh, we're doing TDD, we have a lot of tests. They don't necessarily write it first. They just have a lot of tests. So just say, no, we're definitely test-driven, is that our developers write many, many tests. A very common definition is test-driven design. We're using it as a design technique completely. And a great book that deals especially with this idea is Growing Object-Oriented Systems Guided by Tests. So if you want to understand that specific notion, I highly recommend that book because it specifically deals almost 100% with design. And I am kind of in the fourth camp, which is we are both driving functional development, we're both driving design, but it's not in that kind of extreme religious manner. It's more about a very, very down-to-earth, pragmatic way. So I use TDD to drive new functionality as fast as possible, and I also use it as a design technique to inform my design, but it doesn't mean that I come into the code with no design already done in my head or maybe on a whiteboard. It means that I'll start maybe with some very easy to understand design that's very easy to change if I wanted to, and that's just my rough draft. And then I let the TDD process kind of guide me toward what actually makes sense given what I thought would make sense before I started coding. So it's more of a guidance technique. Okay, so TDD is just 3 steps. You know, I always say that TDD takes 30 minutes to learn the theory, and then it takes at least 2 months to learn it through your muscles. Okay, so the theory is quite simple. In its most glorious, simple form, you make something fail. That is, you write a test that fails. The test should pass if the code was working. So you don't write a bad test. You write a good test that just doesn't work because the production code is missing. Then you make the test pass without touching the test. You only touch production code. By the way, production code is everything that's not a test. And then you refactor the code as soon as the test passes to make sure that you like the code. So this is the process in very, very simple terms. We write the simplest piece of a test that proves the simplest piece of functionality is missing or doesn't work correctly. Okay? And then we run all the tests, and obviously that test should be failing. So imagine that we just got a bug from production that when you click a button, a message should appear and it doesn't appear. My first inclination would be to write a test that proves that the message should appear. And of course, it should fail because the message does not. So then I run all the tests that I have, including this test, and at least one of them should fail. And as soon as it fails, I have permission to go to the production code and write the simplest possible production code that would make this test and all the others pass. So it has to be a very simplistic form. We'll see what simplistic could mean, but there are many ways to think about it. But think very naive. Like if your cousin started coding 2 weeks ago and they knew JavaScript, what is the functional way they would have solved it? Okay, instead of over-architecting or making things too generic, what would they do? That's kind of the way I think about it. And this kind of forces us into writing more tests later, which is why I like this approach. Then, technically, we should run all the tests as soon as we make the change, and all the tests should pass. Of course, if they don't pass, we make the change until the tests do pass. Then, once the tests are passing, we do an incremental refactoring so that we kind of like the code that we created. And we'll do a small one, we'll run the test. We'll do another one, we'll run the tests. So this is kind of a small loop. We repeat this loop until we like the code that we created. So, and then we go back and we write another test. That's kind of the idea. It's an infinite loop. And in this loop, there are 2 main sections, right? In the beginning, it's about writing code that you trust, that you know actually works. But in the refactoring step at the bottom, it's about writing code that you like. So TDD, the idea of just having a code that functionally works is okay. But what I like about it is that I can do the refactoring step because every piece of code that I wrote has a test that covers it and makes sure that it still passes. So then my refactoring feels much safer. So I can do a lot of these kind of small design decisions after the code is working. So there are 2 main places where design happens in the TDD process. It happens at the beginning. And it happens at the beginning because we write a test for code that might not even exist yet. We write the test as if the code already exists, which means we write a test with the code we wish we had. So in that point, we get to write whatever code we want because it doesn't exist yet. The design cost is 0 because there's nothing to change. if we wanted a function or which parameters or a higher order function or whatever we want. The test decides what the design is. And if we don't like the way the test reads, we just change the test until we like the test and the way that it reads. And that will inform what our design is, which means now we'll get to actually write the JavaScript production code and make the test run and, of course, fail. And the design happens in the refactoring step. So the design does not happen in that middle step right there. Let's see if I can make this happen. Let's see. Does this work? No, the other way around? Oh, there we are. Yeah. So there is no design here. The design only happens there and there. You like this? Airport security didn't like it. OK, so this is kind of the basic idea. Are there any questions? We don't have any time, so it doesn't matter. So we're just going to continue. If we wanted to actually practice it, the best way to practice TDD is through your fingers. Okay? You can read about it as much as you want. You can see me doing it as much as you want. But at the end of the day, you actually have to give it a try. And there is a huge difference between seeing someone doing a kata. By the way, a kata is, if you don't know what it is, it's taken from the martial arts world. It's a set of exercises that you repeat. And every time you repeat, you make very, very small adjustments. You make optimizations. And in our case, the exercise is to write code in a test-driven fashion. So what we're actually exercising is not writing the code first, but writing the test first, and then going in very, very small steps. That is a skill. In fact, there are 3 skills that go into TDD. One is writing good tests. Okay, you can write good tests whether you write them first or not, or you can write crappy tests first. Okay, and I've seen that too. The second one is writing the test first. So you can write the test first, and it can be crappy or good. That's a different skill. And the third is design. And to succeed in TDD, I believe you need a little of all of those. But the design is the thing that takes the longest to learn. It's the thing that you should realize that as you practice this, the design thinking will become clearer and clearer. Because what I find is in our code bases, when we go to companies and I do consulting, many people just accept the design for the way that it is, even if they don't like it and they don't realize they have the power to change the design. So that's a skill too, to realize that you can actually change the surrounding around you, the code that you don't like. There are many ways to approach this, but TDD is a good way, and we'll have a bunch of questions and answers about that. We're going to use a special kata that I like to do for TDD in JavaScript specifically, which is called the password verifier. So the aim of it is to write a function. We're not writing a class. We're writing a function called verify. It takes an input, which is a string, and a bunch of rules. And the rules are just predicates. And then it returns a result, which is passed or true or false, and the reasons. Now, for the purpose of this demo, I might even do it simpler. I'll just say that it returns a Boolean because we don't have a lot of time. So let's jump in. And I already heard when I opened IntelliJ that some people said, what? No VS Code, dude. So VS Code is nice. IntelliJ is better. That's all I'm going to say. Okay, what did we want to do? Okay, we wanted to write the verify function. This is the problem with TDD. You want to start something, and you have to remember where do you even begin. So if I wanted to write that verify function, right? This is the slide for it, right? I'm already here in the verifier.js file. What is the first step that I have to do? Can anyone tell me? Just say it. I should write a test, so I shouldn't even be in that file. Correct. What is your name? Marcus gets 2 points. I'll explain to you what the points mean later. Okay, so I guess we should open the spec file. So I just created a spec file, so I'll open it, and of course now we're in the spec file. And it's just as empty as verifier, which sucks. We're going to have to write something. So we start with a test. Doesn't really matter which test framework we're using. I'm just going to use Jest because that's the one I'm using for the demos in the book, and it seems to be kind of working just as well as Jasmine and the other stuff. Really, the syntax of the test framework is almost non-essential. They all eventually kind of do the same thing. Now, there are many ways to write tests in a kind of a Jasmine jest fashion, right? You have describes, and you have tests, and you have specs, and you have a bunch of things. So I just usually use one big describe at the top to describe the object. Let me just make the font a bit bigger. A bit better. And then I'll just describe the verify method maybe, or the verifier. It really depends on what is the requirement. And in there, I could do nested describes, but at this point, I don't need to. I keep it very, very simple. I just write a very simple test. So by the way, I'm not using TypeScript. I'm just using vanilla JS ES 2015 or JS 2015. So it has arrow functions, etc. But you're not going to see a lot of TypeScript here. And again, the reason is some people use TypeScript, some people don't. Maybe eventually at some point when everyone just uses TypeScript, I'll just switch to that. Okay, so the first problem with the TDD is naming things, just like everything else. What is the thing we want to test? Remember, we're trying to write that verify function. We're just writing a test for it, even though it doesn't exist. So this, if you've never done this before, this feels completely alien. We're kind of jumping into like a void. So what should the test be? I mean, there are many ways to test this function, right? Given an input and rules and all that stuff. So can anyone give me an idea? This is kind of a small room, so any ideas on what the first scenario is, should be? Sorry? Yeah, that's an implementation detail. But when we're talking about scenarios, we're talking about three main points of information. We're talking about the entry point, which is our verify. We're talking about the scenario, that is what inputs or what is the current state around the function, if there is a state, and what is the expected behavior. So we already have kind of the entry point somewhere up there. That's the verifier. But we're missing two pieces of information. So the first scenario should, in the name, should say at least two things. Under which conditions do I get what behavior? So what do you think should be the conditions and behavior we check at first? And I'll give you a hint. It should be the simplest possible thing, because in TDD we're trying to work incrementally. Any ideas? Sorry? I'm giving it the password. I cannot check that there is a password. I'm giving it the password. That's the input. It only verifies if the password is OK. So what is the most simple scenario I can test? No password? OK, no password. So remember, the requirement is that given some rules and in an input, it uses the rules to check the input. So if this is the signature, I have an input and an array of rules. I can, whenever I send inputs to something, I can say, OK, I can send an empty input. I can send an empty array of rules. And that is my first inclination. An empty set of rules, because what should happen if there are no rules? Verify should pass or fail? Should pass, right? There are no rules. Dude, it's the Wild West. There are no rules here, right? There's just like Fight Club. No. Given. So sometimes I'll use the word given. Don't. It's not religion or anything. So given no rules, and notice I'm using a comma, it passes. Okay. So that's two informational things that are happening here. So verifier, given no rules, it passes. So now all I have to do is call the verifier. And this is where the design kind of happens, because I can call the verifier in multiple ways. I'm assuming I'm going to have a require for it, right? So, but I'm just going to write a test as if I have everything. So let's say const rules, right? That's our rules array. It's empty. And const result equals verify. Now, what should be the input if there are no rules? Any ideas? Sorry? Nothing? Any other ideas? Can someone say 42 so I can tell you it's wrong? So if the input doesn't matter, I'll just write an input that doesn't matter. Any input. If I write an empty string, it looks suspicious. It looks like it's interesting. And I want the reader of my test to not ask too many questions. As I usually say, imagine the reader of your test is a serial killer that knows where you live. That you do not want them to ask any unnecessary questions. So, any input, I can say, okay, obviously it doesn't matter. No need to call Roy in the middle of the night. Oh, randomizing the inputs. Randomizing the inputs in a unit test, not a great idea. In an integration test, I might agree with you. The problem with randomization is that we don't know what is the input going in, which technically means that we're going to have to calculate our expected output as well. Our asserts are going to have to be calculated dynamically. And that usually means we're going to have to repeat the algorithm from within the production code in our tests, which means if we have a bug, our test will also have a bug and will pass and will lie to us. Okay? So I'll usually use hard-coded values for inputs in unit tests so that I can easily, in my head, just write down the hard-coded expected values so I don't never have to calculate things. In fact, I try to remove any piece of logic from my unit test as much as I can. So any input, these are the rules, right? And what should happen? I should just do an expect because I'm using jest. So expect result, not gestalt, to be truthy. It's good enough. Now, this is the point. Notice I'm just writing it. The test probably, if I'm using TypeScript, won't compile. If I try to run it, I'm going to get an issue. But do I like this test? Because some of you are looking at this, and you might have more experience in the JavaScript world, or you're more accustomed to functional programming, and you're thinking, you know, Roy, this could easily be a higher order function where you have a function called makeVerifier that takes the rules and then returns a function that only verifies. So something like this. Maybe I could do const verify equals make a verifier and only takes the rules. And then this one only gets the input. I can live with that. And the point is, it doesn't matter. The point is the design happens here, and you get to design it the way you want. Because the test is the only thing that currently exists, the design doesn't exist, I could make this change with 0 cost. It's up to me what the design looks like and what I'm comfortable with. For the purposes of this demo, I can just keep it simple. It doesn't really matter. So it can prevent me from doing a bunch of coding. So I'm just going to reduce this here. But in your own kata, you can go ahead and do a higher order function and have fun with it. Now, the next thing I want to do, I want to run my test. So I'm just going to use Wallaby. Does anyone know what Wallaby is? It's actually a commercial tool. You can use just the jest runner and have it listen to the tests. But I'm personally just a happy customer of Wallaby. So I asked them for a free license because I really liked it. I said, hey, I'm writing a book about it. Maybe I'll mention your stuff. But this stuff is actually making me a happy user, want to actually pay for it. So this is what it kind of looks like. I want to have continuous testing, and I want to have continuous feedback. So what it gives me, kind of the green is where the code didn't fail. Red, it gives me the coverage. Black tells me this line didn't actually happen. So you can see the, I don't know if you can see black here, but there's kind of a black thing here. Obviously, there's no verifier. So if I go to the verifier, there's nothing here. It says verifier is not defined. So I'm just going to go here and say const verify equals require. I know you might be using import, it doesn't really matter, but I'm trying not to use any of transpilers in this demo. And I'm just going to use verifier.js. Okay? And you can see immediately, I can see the type, the errors, etc. I can go to verifier, there's nothing here. In fact, let me just move it here to the right. So now we have the test on the left, we have verifier on the right. I'm just going to do an exports. Module exports equals, and we'll just call it verify. So far so good. It says reference error, verify is not defined. So let's just do it. Const verify equals, and then it takes what? An input and rules. And what we can see here is already received undefined. So you can see I'm getting feedback very, very quickly. Let's just remember that the first point in the TDD is to see the test fail and only then pass. So instead of just returning hard coding, passing, or whatever, I'm just going to say return false. And this brings me to the first point, right? Actually, so it should fail, it expected truth, and I'm putting here something that kind of feels like a bug. And this is the point where a lot of people are having issues with TDD. Is that why are you trying to make the test fail? Just make it pass. You already know what you're looking for. And my answer is, this is the only way for me to test the test. That was a good point, I agree. It was the only way for me to test the test. So I want to trust my test. I want to see that it fails when it should, and I want to see that it passes when it should. And when I do this, I get to see that it fails when I have a bug, and it passes when I change it to true. If I started immediately with passing, I wouldn't know if it failed when it should. I would have to maybe debug it, etc. So TDD is one of the only ways I know I can trust my tests. There are now these days tools that do that run the test and they change the code and they tell you which test should have failed but didn't. Those things take a long time to run. And I like this feedback much better. So if I see the test fail, and now I just want to see that it passes, now this is the point where I pass the first rule, right? Make it fail. Now I have to make it pass. How should I make it pass? There are so many ways to make the test pass. Any ideas? Yes? Return true. Are you sure? Wait, is this how you code in your company? Well, someone with a backbone, I like that. But this is actually very important. Let's just see, because it sounds horrible to me, but I'm just going to say return true. And of course, you see everything is green here. And unfortunately, this test is now passed. And when I say unfortunately, I actually mean is that based on the first rule of TDD, you don't get to write or change production code without a failing test. This is horrible production code. Can we all agree on that? You would never write hard-coded stuff. However, we cannot change it functionally. We can refactor it, but functionally, we cannot change the fact that it's hard-coded. So, what do we have to do? You check if the rules are empty where? Where should I check it? In the test? In the return? I don't have to, I cannot change the return. I don't want to add functionality to it. I have all the tests passing. There you go. So now if I hate this code on the right, I have to add tests to the code on the left. That's kind of what I like about it. If you want to prove to me that the code on the right sucks, prove it to me with the test. So I can tell to myself, like now I have two brains. I have the one brain, which is the laziest developer in the world, just saying, just let me go home. Just come on, just get all the tests passing. And on the right brain is like, what if, right? So I have to give the left brain a reason to exist, a reason to kind of do work. So I'm just going to duplicate tests, which usually gives me chills. We'll talk about maintainability in a second. Okay, so what should be the next scenario to prove that the code on the right sucks? Any ideas? Yeah? Given some rule, it should fail. Yeah. What's your name? Eric. 2.5 points. Okay. So now we just get to say, okay, right brain. Given a failing rule, it fails. Sounds good? So what's my failing rule? My failing rule should just be something that takes an input and it returns false, because I don't care. I'm not actually going to write a real rule here. In fact, for the rules, I'm just going to write more tests separately, and I'm going to write the rules in a test-driven fashion. Right now, what I'm dealing with is the algorithm of a function that takes a bunch of rules. And of course, this has to change to be falsy. Sure? Receive true, expected false. Awesome. So now I get to go back to my code again and say, okay, you got me. Now I get to make all the tests pass in the simplest way possible. Any ideas? too complicated, I realized. No, 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 no. What's your name again? Eric. No, Eric has already spoken. Marcus has already spoken. Anyone else? Is there anyone else here named Eric or Marcus? You spoke too. What's your name? 1.5 points. Because it's not a kind of Swedish, whatever. Video guy, you cut this part. It's just, even the sign is telling me, dude, just move on. Okay, okay, okay. So let's just do something simple. Can I just do return rules, the first one, and then call input on it? It's a problem. So you see this test is passing, this test is now failing. Okay? Yeah, I gotta check. So I gotta do if rules length is 0, then turn true. Okay, now all the tests are passing and I'm back into the kind of vibrant mode. At this point I can refactor my tests, or I can go back to the left and say, no, 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 you're still completely cheating here, right? We all agree that we're completely cheating here. However, notice something that's happening. Incrementally, I'm adding more and more functionality. So, right now I support 0 rules, and I support a single rule. Correct? Make sense? I don't support multiple rules yet, but if my manager stopped me in the middle right now and I committed the code, I would have partially working code. Partially working code, which is much different than what we usually do, which is spend a few days on not working code, and then one day it magically works. Here it works incrementally, and incrementally is part of the fun of working in TDD. We have like 9 minutes left. Okay, so I'm just gonna, at this point, I might say, okay, given one passing rule and one failing rule, you're still failing. But I'm gonna change. I'm gonna basically do a test that looks like this. Given one failing and one passing, fails. So in this case, I might say input true. Okay. So now I have received true. It's expected to be falsy, and you can see here in the production code I have red, green, I have a bunch of stuff here. I can see which tests were failing and what was the reason. And this is very important because at this point I can just now do, okay, let's do const failed equals rules, and then I don't know, map rule to a and give me the result of that rule on input. Right? And do a filter and only give me the ones where the result is false, right? And now all I have to do is to say return if failed equals failed length is 0. So now I have kind of a dramatic effect here where everything becomes green. And the idea is that I can go through and add more and more requirements, and we can go through and add more and more stuff. But notice that this is the point where I would start maybe to refactor some stuff, maybe to move things away. Maybe you know what? Maybe I can even delete code, which is my favorite activity in the world. Oh yeah, I could delete that stuff and it works. And that's part of the fun. I can remove code, I can refactor it, I can optimize it, as long as I don't change the functionality. So that's kind of the basic idea of a TDD structure, the process. And I want to cover a few common questions before we finish. So my first question is, why do we write the test before we write the code? Does anyone remember? Of course, it's Eric. Yeah? It's a reliability. You want to trust the test? No, that's about failure. We write the test before we write the code because we never have time to write it after. Remember that. Okay? If you write the test before you write the code, you always have time. And this is an organizational issue. If we start with a test, we always have time. And there are more things. We think about the design and the API. A lot of times we'll write more tests that are more pinpointed into different things because we write the test first. Now the question is, of course, for 5-point Eric is, why is the test failing? Why do we want a test fail first? Does anyone remember? To test the test, exactly. Who said that? What's your name? Chris. Chris, I'm going to say, because of how quick that was, 3.5 points, I haven't decided what they are. Okay, why make it fail first? We trust the test. True, correct. There are a bunch of other things. We have a very small problem to solve, so there's a psychological issue too. If I have something that kind of fails and then it passes, it feels good. I like to feel good when I'm programming. It's part of one of the reasons I program. If I stare at something and it's a huge problem and I don't get to solve it as soon as possible, sometimes it can be days. It sucks. It's just there's a terrible feeling about it. Okay, we want to solve things as simply as possible because simpler solutions are easier to maintain. Okay, and also it makes us think about other tests that we didn't write. Because remember, the right brain and the left brain are kind of playing against each other, which is one of the reasons when I kind of teach TDD in classes, I split people into pairs and they have to work together. And what I recommend is that one person writes the test and then the other person has to solve the test in the simplest way possible. And every couple of tests you switch roles. It's called ping pong pairing. And it's a lot of fun because one person gets to play the laziest developer in the world and the other person just gets to nail them every time, say, and it's so much fun. There's something to be said for, annoying other humans. Okay. The refactoring part we didn't cover a lot because we didn't have a lot of time. But the idea in refactoring is that this is the point where you you make the code something you would like to see. Because if at the beginning we solve things in the simplest way possible to force us to write new tests, etc., in this part we get to write the code that tomorrow morning when we wake up, we're going to be proud of ourselves, that we wrote that code, that it's easy to read, that it's easy to maintain. Functionally, it looks and acts exactly the same, and the entry point where we invoke the code looks exactly the same. Okay, the incremental work is very, very important. 60%. The name of the study is in the comments for the PowerPoint when you download them. But the study maybe 12 years ago, showed that 60% of the code that we write never gets used. So imagine how many features exist in Word or PowerPoint or anything else that we have never used. We don't even know that we don't know about it, right? Just the amount of buttons. There are buttons to show more buttons that you don't know that those buttons exist, okay? Just the macros and all, there's just so much functionality. But so when we write code, we say just in case we add one more parameter, we add one more function, we add one more property, whatever we need to do, if the test doesn't require it, then we don't do it. And if we want to do it, prove that we need it with the test. And this kind of saves us from ourselves because we like to make things more and more generic. We like to make things to fit into the future much more. But when we do that, we write code that is much more complicated, which means that it might take me 2 weeks to write that code instead of 2 hours. And in those 2 weeks, someone might take me away from my task and I'll have to work on something else. So now whatever I did isn't working, and I might not never come back to it. If I work on simple code incrementally, whatever happens, whenever you stop me, I have something working and I can stop working on it. I can come back to it later. Okay, here's a fun question. Why not write many tests at once? Why not, I made it black just so you can see me. Why not just write, let's say 20 tests for this kata and then solve them? Any ideas? That was my first inclination when I started TDD. Yeah. Okay, so when you do it in a more evolved way, you will learn more about the requirements and the design might change, etc. Awesome. That's one good reason. Any other good reasons? Yes. It will make the solution more complicated. Another amazing reason. Anything else? Yeah? No, not Marcus. Yeah. Sorry? Priority. Oh, I like that one. I didn't think about that one. I'm going to add it to the slide. Yes. Yes, it's less incremental, I agree. My question is, why do people tend to do it less incremental? And here's another answer. Let's see if I agree with you. Hopping between tasks can leave stuff undone. Small units of work are easier for people, means better life. Something working is better than nothing. The priority thing is missing there. But so it's a much bigger problem to solve, is something you already said. That's awesome. There's longer time to a green bar feeling. That second line, I love it so much. Because if I had 20 tests in my demo and they would all be failing, and one by one, I would make them pass, green, okay? My inclination as a human is, first of all, it's not green until it's all green. So it feels like a failure for a long time. The second thing is, if I have many tests to write, I'm going to try to make as many of them pass in the single change. Agreed? I'm smart enough. I'm going to make 5 of these tests pass just by adding these couple of lines. And that's how you end up with regular expressions, by the way, just so you know. Okay? So we try to be too smart for our own good. So when we have small problems, we make the code much simpler because we don't try to solve a much bigger problem, which is 5 or 20 tests. Let's see. Last but not least, we have to finish. So I'm just going to give you some resources to continue. If you want to see the TDD katas that I like to do, just go to this URL at the top. TDD by example by Kent Beck is a great book. Growing Object-Oriented Software Guided by Tests. Another great book that talks about design. And of course, my own book, which I forgot to mention here. So integration test failed, obviously. If you want to catch me or ask me a question, you can just email me. You can find me on Twitter. You can read my blog. You can go to my website. Thank you very much, everybody. May the force be with you.